المفروض يبدأ التسجيل. كده بدأ التسجيل. تمام، نكمل بقى. تمام. احنا كنا فين؟ ثانية. وهنا بيقول إن لو في مثلا كلمة فيها اللي هي possessives وفيها يعني فيها مثلا حاجة يعني مثلا لو فو دي مثلا كلمة، تمام، فو apostrophe s عادي لو هي هو المفروض يقول إنها false، يعني هي مش الكلمة دي غير صحيحة لو هي مش في الديكشنري يعني. تمام. وهنا بيقول إن هو هيكون الديكشنري اللي انت هتعمله بس البروجرام بتاعك هيكون يعني الاستراكشر بتاعه هيكون زي بتاعه. تمام. alphabetically sorted يعني مثلا من A to Z، تمام، من فوق لتحت، وكل كلمة ليها سطر وكل وكل سطر بينتهي بسلاش n اللي هي يعني زي نيو لاين. وبعديها بيقول ثانية. تمام، هعدي بس الحتة دي اشرح لكم الفيديو وبعديها هشرحه لكم، ولو في اي حد عنده استفسار اتفضل. انتوا سامعين الصوت بس؟ سامعين الصوت بتاع الفيديو؟ سامعين الصوت اللي في الفيديو؟
ايوه الصوت واضح.
تمام.
Speller, you're going to be to write a spell check that can take a text and take every word in that text and check to see if the word is spelled correctly or not. And importantly, do so as quickly as possible. How are you going to do that? Well, let's first take a look at the distribution code that you'll be given in this problem. We're going to give you a file called speller.c, which contains the code that will do the spell checking, calling upon the functions that are going to be declared in dictionary.h. So if you open up dictionary.h, you'll see the function prototypes for 5 functions that you're going to implement in this problem. In dictionary.c is where you are actually going to write the implementations of these functions. Makefile is going to contain some commands that will compile all our files together into a finished program. And then we've given you 3 directories or folders. A dictionaries directory, which will contain both a large and small dictionary of words, a text directory that will contain some sample files that you can run your spell checker against, and we'll give you a keys directory, which will contain the solutions, the list of words that are misspelled in each of the sample text that we provide to you. So let's take a closer look at dictionary.c. Dictionary.c is the file that you'll have to edit in this problem to make this spell checker work. What are the 5 functions that you'll need to implement in dictionary.c? Well, the first is called load, which is responsible for loading all of the words in the dictionary into some sort of data structure, like a hash table. Next up is a function called hash, which is going to take a word and run a hash function on it, returning some number that corresponds to that word. Next up is size, which is just going to return how many words are in your dictionary. Next is check, which will take a word and answer the question of, is this word in the dictionary or not? In other words, is it correctly spelled or not? And finally will be unload, where any of the memory that you've had to allocate in order to store data inside of your data structure, you'll now need to free up and give back to the computer. So these are the 5 steps for Speller, and we'll take a look at each of them one at a time, so that by the end of it, you'll have a working spell checker.
تمام. هنا في الفيديو ده كان كده زي اوفر فيو عن في الفيديو ده كان بيدي كده اوفر فيو عن المشروع اللي انتوا ان شاء الله تعملوه. تمام. بيتكلم هنا عن الفانكشنز اللي انتوا هتعملوها. تمام. دي بس اللود دي هجيب الكلمات، يعني هنا بيقول هجيب كل الكلمات اللي في الديكشنري ويدخلها في نوع من الداتا ستراكشر اللي هو ممكن تكون ايه، ممكن هاش تيبل. تمام. وهاش فانكشن كده هتدخل له اي كلمه وبعديها هيرجع لك رقم. تمام. الرقم ده الفاليو بتاع الكلمه دي، بيدي فاليو لكلمه معينه. تمام. سايز دي هتدي حجم الديكشنري. تمام. يعني هيقول الديكشنري ده قد ايه. وبعدها في تشيك فانكشن دي بتشوف الكلمه دي اذا كان هي صحيحه ام لا، يعني على حسب الديكشنري اللي معاك. وفي الانلود دي بقى اللي هترجع الميموري اللي انت عملت له الوكيت في البرنامج بتاعكم، هنرجعه للكمبيوتر تاني بعد ما احنا كنا خدناه في البداية. تمام. لو حد عنده اي سؤال عن الفيديو ده يتفضل. محدش؟ تمام. انا عايز اعرف هو انتوا وصلتوا فين في الكورس. يعني ممكن تكتبوا لي في الشات انتوا يعني كل واحد فيه كام، عشان بس ايه، عشان مين وصل ومين لسه ما وصلش. تمام. تمام. يعني في منكم يعني البروبلم في بروبلم سيت 5. تمام. دلوقتي هنبدأ في الفانكشن الأولى اللي هي اللود. تمام.
Your first task in Stellar is going to be to implement the load function, which is responsible for taking the dictionary and loading it into a hash table. How is this going to work? Well, the load function will take as its argument a char star or a string, which is the dictionary file that you're going to have to open up and read from in order to load all this data into your load function will take as its argument a char star or a string, which is the dictionary file you're going to have to open up and read from in order to load all this data into your hash table. It's going to return a Boolean value, true if you were able to successfully load all the data into your hash table, and false if there was some sort of memory error, like not enough memory available to allocate, for example, or a file that couldn't be opened. So let's take a look at how you're going to do this. Well, ultimately, when you open up this dictionary file and store all of the words in memory, you're going to store them all inside of a hash table. And recall that a hash table is really just an array of individual linked lists. And the way you determine which of those linked lists you're going to insert a word into is based on a hash function. Function that in this case is going to take input, a string or a word going to put in the dictionary, and the output is going to be some number that you're able to generate from that input, which is going to correspond to which of the linked lists you want to place this particular word into. Let's take a closer look at hash tables to get a better sense for how they work and how they're going to be useful for this load function. Here, for example, I have 5 words that I would like to store inside of my hash table: apple, banana, bat, car, and book. And I could take all of these words and just put them in a single linked list. But then I'd have a pretty long linked list of 5 words that I would have to traverse if I wanted to find whether any one particular word was inside of my data structure. Instead, I can put them into a hash table, creating several buckets, so to speak. I'll create an A bucket for all words that begin with the letter A, a B bucket for all words that begin with the letter B, and a C bucket for all words that begin with the letter C, and then associate each of those words with a particular bucket. So for example, apple ends up in the A bucket, bat, book, and banana end up in the B bucket, car ends up in the C bucket. What I've used here is a hash function, a function that takes it.
نعم. تمام.
apple or bat or book as input, and out which of the linked lists, the A linked list or the B linked list or the C linked list, that I should place this particular word into. So what exactly is a hash function? Well, a hash function in this case is going to take a word as input, and it's going to output a number corresponding to which bucket or element within this array we want to store the word in. Because recall that a hash table really is just an array, where the very first linked list in that array is at index 0, and then 1, and then 2, and then so forth. And so a hash function is going to take the word and output which index into that array we should use to place that particular word. And at each index inside of the hash table is going to be a linked list. And what is a linked list again? We'll recall that a linked list is data that's comprised of nodes, where every node has a value, as well as a pointer to the next node. So for example, in the case of our spell checker, we're going to have a hash table, which is an array of linked lists, and each of those linked list nodes is going to have a value, some place to store a word, which in this case is going to be a character array, which can store words up to the maximum length of any word, as well as a pointer to the next word. What does this look like? Well, if you look at the top of dictionary.c, you'll see the definition of a node here. We've type def a new node, creating a node where every node has a word, which is a character array, as well as a pointer that is going to give us the address of the next node in this linked list. So our hash table is going to give us the first node in the linked list, and from there we can get to the next node, and the node after that, so on and so forth, until we get to the end of the linked list, where we're just going to find the value null. Then immediately below that in dictionary.c, you'll also notice this. We defined const int n to be equal to 1. In other words, we defined a constant integer, which is called n, which we've initially set to 1, and now said that table is going to represent our hash table, and it's going to be an array of node pointers, an array where every element in that array is a pointer to a node. Right now, this hash table has only one element in the array. In other words, there's only one bucket in the hash table. So you'll likely want to change n, set it to some higher value, so your hash table can have more buckets, and therefore spread data out a little bit more evenly. Initially, though, your hash table is going to be empty. So how are you going to be able to add more data to that hash table? Well, to do so, you're going to need to allocate memory for a new node, and then put some data into that node. In order to allocate memory for a new node, I might have some code that looks something like this. Node star n equals malloc size of node. Malloc here means allocate some memory, fast memory from the computer. And how much memory do I want to allocate? Well, size of node is going to be the number of bytes of memory that I need in order to store a node. So malloc size of node is going to give me just enough memory to be able to store a node. And I'm going to store the address of that node inside of n. How do I then put data into that node? Well, remember that a node has two properties to it. It has the word itself, as well as a pointer to the next node. So I might say stir copy n arrow word and then hello. What is this going to do? Well, stir copy is short for string copy. It's going to copy a string from a source into a destination. In this case, it's going to copy the word hello into the character array n arrow word, which is the word field of this node that I've just created. I've copied the word hello into that space of node. In order to set the next pointer, if I knew what the next node was, I could set it right away. If I don't know, I could just set it to null. N arrow next equals null means right now nothing comes after this particular node. Of course, in your linked list, some of these nodes are going to have other nodes that are the next node in this sequence of elements inside of the linked list. So what exactly do you need to do now inside of this load function? Well, the first thing that you're going to have to do is open up this dictionary file. Next, you're going to read strings from that file one at a time, one word in the dictionary. For each of those words, you're going to create a new node, some node that is going to have a value and a next pointer. And you're going to hash that word using a hash function to obtain a hash value, an index into your hash table to determine which of those linked lists you should use when you're inserting this node into a linked list. And then finally, you're going to take each of those words and insert into the hash table at the location given by your hash function. So let's take a look now at each of these steps one at a time. Let's start with how you're going to open the dictionary file. Recall that the argument to the load function is a char star or string representing the dictionary file you're going to use for the loading. You can use the fopen function to open up that file, and then make sure to check if the return value is null to make sure that you were able to successfully open up the file. If you weren't able to successfully open up the file, your load function should return false. Otherwise, you'll be able to keep going to the next step of the load function. The next step is to read strings from the file. And for this, you can use a function called fscanf, short for scanning from the file. The first argument is going to be that file pointer, the result of calling fopen on the dictionary file. The second argument is %s, meaning you want to read in a string. And the third argument is word, which is going to be some character place where you're going to read the word into. In other words, character array inside of memory, where you can then access all of the individual characters of the word after you print the file. And you're going to want to repeat this again and again and again for each of the words in the dictionary, calling fscanf on the file over and over, getting one word at a time until fscanf returns EOF. And that will happen once fscanf reaches the end file. So when fscanf returns EOF, that's your sign that you've finished reading all of the words in the dictionary. But you'll likely want to have some sort of loop that's running fscanf again and again on one word after word after word until you get to the end of the file. What are you going to do for each of those individual words? Well, the next step is going to be to create a new node that is going to store that particular word inside of your hash table. How to do that? We'll recall that the malloc function you can use to allocate memory. So you'll want to allocate enough memory to store a new node. Be sure to check if malloc returns null or not, because if malloc doesn't have enough memory to be able to store the node, it'll return null and your load function. Once you create that node, you're going to want to copy the word into that node. Now that we've created the node, the next step is to figure out how it is we're going to insert this node into the hash table. Recall again that a hash table is just an array of linked lists, and we now need to determine which linked list we should use when we're determining where to place this particular node that we've just created. And to do that, we're going to hash the word. You're going to use the hash function, which is defined in dictionary.c, which will be a function that takes a string and returns an index, some number that you can use to index into your linked list. Right now, we've given you a hash function that just returns 0 for every particular input. And later in this assignment, we're going to replace this hash function with a better hash function. But for now, you can just call upon the hash function inside of load to determine which index into the hash table you should use when you're inserting this new node. Once you've determined which linked list you should use, the next step is to actually insert that word into the linked list. How are you going to do that? Well, again, recall that the hash table is an array of linked lists, and you're going to want to index into the hash table to get the linked list that you want to use to add this particular word into. And in order to do that, you're going to have to add a new node to a linked list. So you want to be sure to make sure you're setting your pointers in the correct order. What do I mean by that? Well, let's take a look at an example. Here up at the top, imagine that head is a variable that points to the start of a linked list. The linked list is bat, and next is book, and next is banana, and banana here points to null, for example. And let's imagine that I have this new node, which is this blue node that I've just malloc, and I want to add it to this linked list. So if I wanted to make this new node head of the linked list, one thing you might imagine that I would do is point head to point at this new node that I've just created. But what's just happened? Now that I've set head to be blue, this very first node inside of this linked list, I've now lost access effectively to all of the other nodes that were previously in the linked list. I have no way to get to them because both head and new node both point to just this blue node, and blue doesn't point to anything else. So what is the actual solution here? Well, the first thing that you're going to want to do is probably to take this new node, in this case blue, and set its next pointer to be the first element in the linked list. Then after that, you can reset head, in other words, the first element in the linked list, to be the new node that you just created. Now, the beginning of the linked list is blue, and next comes bat, and then book, and banana, and we've been able to represent all of these words now together inside of a single linked list by adding our new node to the beginning of the linked list. And you're going to repeat this process for every word in the dictionary, reading that word using fscanf, allocating enough memory in order to store that word, copying the word into the node, and then inserting that node into one of the linked lists in your hash table based on the result of calling your hash function. After you've done that for each of the words in the dictionary, you'll have successfully loaded all of your data into memory into a hash table such that you can now begin the spell checking process.
تمام. كده خلصنا الفيديو بتاع لود. تمام. هنا بقى كان بيشرح ازاي كان فيها اللي انتوا هتعملوه. اهو دي تو دو. تمام. فاول حاجه هتعملوها انكم تفتحوا الديكشنري فايل اللي هو هيكون زي بارامتر كده للفانكشن بتاعتكم، هتاخدوه وتفتحوه. تمام. وبعديها هتاخدوا السترينجز اللي في الفايل دي، يعني هتاخدوا كل كلمه في الفايل دي وفي كل مره هتعملوا نود جديده. النود دي بقى ايه؟ النود دي داتا ستراكشر. تمام. معموله وفيها مكان انكم تحطوا كلمه، وفيها مكان تاني بوينتر. البوينتر ده بيشاور على ايه؟ ده هو لو يعني مثلا لو هو في وسط اللينك ليست بتاع الهاش تيبل بتاعتكم، ده هيكون باصص للكلمه، يعني بيشاور للكلمه اللي بعدها. تمام. وعشان تعرفوا في اي لينك ليست من الهاش تيبل، اصل الهاش تيبل دي زي الليست من لينك ليست. تمام. انتوا عشان تعرفوا اي لينك ليست هتدخلوا الكلمه دي، هتشغلوا الهاش فانكشن. الهاش فانكشن دي انتوا يعني هتظبطوها بعدين ان شاء الله، بس هي دلوقتي معموله انها بتعمل ريتيرن زيرو. تمام. وبعد ما تعرفوا الهاش بتاع، يعني لما تعملوا هاش للكلمه دي، هتدخلوا بقى الكلمه دي في اللينك ليست بتاع اللينك ليست ده. تمام. اللينك ليست هتدخلوا فيها بقى هتدخلوا هتدخلوا كلمة في اللينك ليست ازاي، او النود دي في اللينك ليست ازاي؟ هنا لو احنا خلينا الهيد، او يعني ده خلينا ده يبص على دي كده، هنعمل يعني مش هيبقى لينا اكسس للباقي ده كله. تمام. فاول حاجة هنعملها ان نخلي البوينتر بتاع بلو ده يبص الباك، والهيد بعدها يعني تبص لبلو. ف... فنكون دخلنا دي من غير ما نعمل لوز اكسس لكل ده. تمام. وهنا بقى بيشرح بقى بالتفصيل هتعمل، يعني هتدخل يعني هتعملوا ايه بالظبط. بس انا كنت بشرح لكم كده باختصار، يعني ممكن ثانية دي بس كده. اهو. تمام. لما تفتحوا هتستخدموا اف اوبن، وتكتبوا لو مثلا لو حصل في مشكلة في الفايل وانتوا بتفتحوه، او اقصد لو الريتيرن فاليو يعني null. تمام. و في تفاصيل ان شاء الله هتدققوا فيها اكتر، بس انا بس بشرح لكم كده بانجاز. تمام. لو حد عنده اي سؤال في اللود فانكشن يتفضل. حد سامعني؟ حد سامع؟
ايوه هندسة، بس انا عندي الصوت هنا بيقطع. انا الصوت بس عندي بيقطع من قبل، احتمال من شبكتي انا.
آه. انا لو كلكم واصل لي ما اظنش المشكله عندي في الشبكه. طب طب يعني انت عندك اي سؤال في اللي انا شرحته؟ م? ثانيه، هو في حد ما كانش سامعني؟
الو.
ايوه، في حد بيقول انه مش سامع. الناس بتمشي ليه؟ لو اه سامعني؟ لو في حد عنده اي سؤال يتفضل. هكمل. التانية هي الهاش فانكشن. تمام، ده اللي انا قلت عليها ان هي هتاخد كلمة وهيقول هيرجع فاليو. الفاليو ده هنستفيد بيه في ايه؟ ان احنا لما احنا نعرف هندخل الكلمة دي او النود دي في اي لينك ليست. اصل احنا قلنا ان النود دي هيبقى فيها الجزء للكلمة وجزء بوينتر كده يبص على الكلمة اللي بعدها، ده لو في كلمة بعدها. تمام، فالهاش فانكشن دي هترجع لنا كلمة، هترجع لنا رقم. الرقم ده هنستفيد بيه ان احنا هنعرف ندخل الكلمة دي او النود دي فين، النود دي فين. تمام.
When you're loading words into your dictionary and when you're checking to see if a word is spelled correctly or not, you should use in order to find that word or insert the word in it. So what is the hash function? Well, the hash function is going to take a char star or a string of input representing the word you're going to hash, and it's going to return an unsigned integer, an integer that won't be negative, representing which index into the hash table you should use that corresponds to that particular word. So what does your hash function need to do? Well, it needs to take as input a word, and that word is going to have alphabetical characters, and it may have apostrophes in it as well. And the output of your hash function is going to be a numerical index between 0 and n minus 1 inclusive. Recall that n is defined at the top of the file and is the total number of buckets in your hash table. In other words, the length of that array of linked lists. You by default set n equal to 1, but you can and should set n to be some larger, using more buckets in your hash table, and therefore can spread your data out a little bit more, making for faster search times. And importantly, your hash function should be deterministic. If I give it the same input again and again, I should get the same output. Such that when I'm loading insert apple into that index into the hash table, and then when I'm checking to see if the word apple is spelled correctly or not, I should be able to call the hash function on the word apple, get the same value as before, and then check only that particular linked list in the hash table to see if the word apple is there or not. So you'll need to decide on a value of n, the number of buckets that your hash table is going to have, in other words, the length of your array, and also the possible values that your hash function can return. A larger n value means you have more buckets in your hash table, and therefore data is spread apart more and could potentially mean faster search times. But you'll need to make sure that the output of your hash function is some value between 0 and n-1 inclusive, because those will be the only valid indices into your hash table. If your function were to end up with a value greater than n, you can always take that value mod n, or the remainder when you divide by n. In other words, get a value that's in the appropriate range. Now, what are some examples of some hash functions? Well, a very simple hash function might just take the first letter of the word. If the first letter of the word is A, then the hash value is going to be 0. If the first letter of the word is B, the hash value is 1, so on and so forth. If the first letter of the word is Z, the hash value might be 25. In this case, your value of n is 26, because you'd have 26 different buckets, one for every letter of the alphabet. Of course, 26 isn't very many buckets, especially considering the fact that the large dictionary that we're going to give you contains more than 143,000 words. So you might consider using other hash functions, like looking at the first 2 or 3 or more letters, or doing some sort of math using all of the individual values of the letters. And for this part of the problem set, you're certainly welcome to look online for other hash functions that already exist and use an existing hash function that you find online, provided that you cite the source of any hash function that you do find. But once you've completed the hash function, you'll now have the ability to take a word and determine which of the linked lists inside of your hash table it should correspond.
تمام، فهنا شرح يعني الهاش فانكشن. الهاش فانكشن دي زي ما قلت هتدخل لها كلمة وهترجع رقم. تمام، فهنا شرح حبة هاش فانكشنز ممكن تعملوها. بس الهاش فانكشنز دي يعني مش هيبقى فيه باكيتس كتيرة، فمش هيبقى فيه لينكد ليستس كتيرة، واحنا عايزين زي احنا يعني عايزين ان السيرش يعني او السيرش في ان يعرف هي كلمة صح ولا لا، عايزينها اسرع حاجة او سريعة جدا. تمام. فاحنا بنستخدم الهاش فانكشن عشان نعرف احنا هنعمل تشيك في اي لينكد ليست. فبدل ما اتاكد في كل لينكد ليست عشان اعرف هي الكلمه دي موجوده في الديري ولا لا، اصل الديكشنري ده تخيلوا يعني 100 اكتر من 143 الف كلمه. تمام. فعشان لو انا مثلا خليت في لينكد ليست واحد هياخد لما يخلي كلمه صح ولا لا وكده. فعشان كده كل لما فاللينكد ليست دي يعني كل لما تزيد كل لما تكون في البحث هي عن الكلمة هي صحيحة أم لا. تمام. فهنا قال first letter يعني هيكون في 26 linked list، يبدأ من 0 لحد 25 في ده مش كتير، ممكن حاجة بتستخدموا كل الحروف اللي في الكلمة، بس يعني ده لو انتوا عايزين. وممكن تجيبوا حاجات على النت، يعني ممكن تلاقوا هاش فانكشنز حلوة على النت، ممكن تسرع. وكل لما البحث يعني يكون أسرع يكون أفضل. تمام. لو حد عنده أي سؤال يتفضل. محدش عنده سؤال؟ طيب نكمل. الفانكشن الجاية دي اسمها size. تمام.
In the size function, you'll need to return the number of words that are in your dictionary. There are a number of ways you might do that. You might imagine iterating over every single one of the linked lists inside of your hash table, counting the number of nodes inside of each of the linked lists. Or you could imagine that as you're loading the hash table, you could somehow keep track of the number of words you've added to the dictionary so far, so you can return that value in your size.
السايز فانكشن دي بسيطة جدا. تمام. ده نرجع عدد الكلمات البنري. تمام. فممكن تعملها يعني ممكن تعملها يعني تعمل iterate، يعني تعمل لوب كده على كل linked list عشان تعرف عدد الكلمات اللي فيه. او ممكن كل وانت بتعمل اللودنج الهاش تيبل اللي انت عاملها، ممكن تقدر تعمل مثلا ايه keep track يعني يكون معاك مثلا variable كده او يعني تعمل keep track، يعني تكون عارف وانت بتعمل لود عدد الكلمات اللي انت عملت لها لود. تمام. حد عنده اي سؤال؟ اتفضل. انت سامعني اصلا؟ حد سامعني؟ الصوت بيقطع. طب ثانية. كده احسن. تمام. ظبطت بس حاجة، ولو في حاجة فاتتكم أو أي حاجة ممكن تشوفوها في التسجيل يعني. لو في حد عنده الشبكة سيئة يعني ممكن يشوف التسجيل، أنا إن شاء الله أرفعه. تمام. فهنا أنا السايز فانكشن دي هترجع عدد الكلمات اللي احنا عملنا لها لود. تمام. ممكن تعمل يعني ممكن تسجل او يعني تعمل كيب تراك يعني من عدد الكلمات اللي انت عملت لها لود ده، يعني دي طريقة. او ممكن تعمل لوب على كل لينك ليست عشان تعرف عدد الكلمات اللي فيه. تمام. هننقل دلوقتي الفانكشن اللي بعدها اللي هي التشيك بقى، اللي هنعمل بيها التشيك، يعني اللي نعرف هي الكلمة صح ام لا. تمام.
In the check function, your job is to take a word and check to see if the word is in the dictionary or not. The check function will take a char star with string representing the word as its input, and the output will be a Boolean variable, true or false. So, what does the check function need to do? Well, your function should return true if the word is in your dictionary, and it should return false otherwise. And importantly, your check function should be case insensitive. It shouldn't matter if some of the characters in the word are uppercase or lowercase. Your spell check will still be able to detect whether or not the word is in the dictionary, regardless of case. So, what are you going to need to do? Well, the first step is going to be to take the word and hash the word using the hash function you implemented earlier in order to obtain a hash value. Then you'll access the linked list at that hash value, that particular index in your hash table. Array of those individual linked lists. Once you've accessed that individual linked list, word is in the dictionary, it's going to be in that list. Then it's not. You can traverse that linked list, looking for the word in question, and using the stir case const function, which is similar to stir const, which compares two strings, but stir case const will compare two strings case insensitive, so it won't matter whether the word is uppercase or lowercase in order to find the word. If you find the word, your function will return, and otherwise your function will return false. How do you traverse a linked list though? Well, let's take a look at an example. Here, let's imagine that head is a variable that is declared to be first element in the linked list. In this case, the word bat, which is inside of a node that points to a node that has the word book, which points to banana, for example. How might I traverse that linked list? Well, you could imagine that I could set up a variable called cursor, for example, which initially is a pointer to the first element in the linked list. And I might check, is that the word I'm looking for? And if it's not the word I'm looking for, then what I'd like to do is take the cursor and move the next node in the linked list. Well, where is the next node stored? It's stored inside of the next field, inside of the node that I'm currently looking at. So if I were to use syntax like cursor equals cursor arrow next, that would mean to take cursor and set it equal to whatever cursor's next pointer is currently pointing to. So that would move cursor to the next node in the linked list. And I could check this to see if this is the correct one. Again, using the stir case const function to compare two strings to see case insensitively whether they contain the same character. If that's not right, then I might repeat the process, like cursor equals the cursor arrow next to move the cursor to the next node. If I ever find the word in question, I'll go ahead and return true. But when do I stop? You might imagine that this is happening in some sort of loop, and eventually I'll reach the end of the linked list, where at some point I'll set cursor equal to cursor arrow next, and at the end of the linked list, we'll have is null. So if we move forward, cursor equals cursor arrow next, and eventually cursor becomes null, that means we've reached the end of the linked list, and the word wasn't found, which means the word isn't in our dictionary, and our function should at this point return false. So as a brief recap, how are we going to traverse this linked list? You'll start with some cursor set to the first node inside of your linked list, and then you'll keep moving the cursor, setting it equal to cursor arrow next over and over again, checking each word as you go until you get stuck. If you find the word along the way, then that means the word is in the dictionary and you can return true from this function. Otherwise, if you reach the end of the list, then the word is not in the dictionary and you can return false. As a
ده كان شرح رجع بس للحتة بتاعت التودو وبعدين اشرح له. تمام. احنا في التشيك فانكشن دي هناخد الكلمة، تمام، وبعديها هعملها هاش. هعمل الهاش ده بقى ليه؟ هستفيد من ايه في الهاش ده؟ هروح لللينكد ليست اللي في الهاش دي، او يعني في الاندكس بتاع الاندكس بتاعته بيساوي الهاش دي. تمام. وبعديها همشي مع اللينكد ليست دي. تمام. عشان اعرف هي الكلمة دي موجودة في الديكشنري ولا لا. تمام. وبرضه مهم جدا انكم تعملوا تشيك حتى لو الكلمة فيها كابيتاليزيشن او لا. يعني لو هي كابيتال برضو، لو الكلمة دي في الديكشنري لازم يعمل ريتيرن ترو، لو هي مش في الديكشنري لازم تعمل ريتيرن فولس. تمام. فهو التشيك فانكشن دي بتعمل ريتيرن ترو لو الكلمة موجودة او لا. تمام. وهنمشي في اللينك ليست دي ازاي عشان ندور على الكلمة. هنعمل مثلا حاجة زي كده. تمام. ده هيبص لبداية اللينك ليست دي. تمام. وبعديها لو الكلمة دي هي يعني هنشوف، يعني واحنا بنعمل ترافيرس اللينك ليست ده هنشوف هي الكلمة دي صح ولا لا. لو هي لا هنروح للكلمة اللي بعدها ونفضل نعمل كده. تمام. لحد ما نشوف لو احنا وصلنا نل، يعني لو الفاليو بيساوي نل، لو بيساوي نل يبقى كده خلاص هي اصلا مش في الديكشنري بتاعتنا. تمام. فاهو هو هنا بينقل الكرسر من كلمة لكلمة يتأكد هي الكلمة دي موجودة ولا لا. ممكن نستخدم كرسر equal كرسر arrow next. تمام. لو حد عنده أي سؤال يتفضل. وانتوا فين الشاشة؟ الشاشة قفلت. انتوا شايفين الشاشة؟ يا جماعة حد شايف الشاشة؟ شايفة؟ ده شايفة؟ كده شايفة؟
لسه ما واضحة، ما ظاهرة.
لسه؟ كده؟
أيوة ظهرت.
تمام. أي استفسار في هنبدأ الانلود فانكشن. الانلود فانكشن دي هترجع الميموري للكمبيوتر بعد ما انت عملت له الوكيشن. بعد ما استخدمته مالوك دي بتعمل الوكيت حبة ميموري، بتعمل الوكيت يعني ميموري عشان تستخدموها. ومهم جدا انكم ترجعوا الميموري دي تاني للكمبيوتر. تمام. هنشوف بقى الانلود فانكشن دي.
The last step to completing your spell checker is to implement the unload function, which is responsible for freeing up any memory that you've allocated in the process of running your spell checker. What does this mean? Well, remember that anytime you dynamically allocate memory using malloc, it's also your responsibility to call C on that memory to free up that memory and give it back to the computer. So what is your unload function going to do? Well, your unload function is going to call free on any memory that you've allocated using malloc and return true if it's able to do so successfully. How are you going to do that? Well, remember again that your hash table is really just an array of individual linked lists. Each of those linked lists contains nodes you allocated memory for, likely using malloc. So you'll need to free each one of those nodes. So you might imagine iterating over your hash table, going over each of those individual linked lists and calling free on all of the nodes inside of those linked lists. But how do you free all of the nodes in a linked list? Let's take a look at an example. Here again is a linked list where we have a variable called head, which is going to be a pointer to the first element in the linked list. In this case, a node that has the word bat in it, which has a next pointer that points to book, which has a next pointer that points to banana. And let's imagine how we might free up these nodes that we've allocated using malloc. You might imagine again that we could have a variable called cursor, which is set equal to this node here, is a pointer to this node bat. If I wanted to free this node, which I originally allocated memory for using malloc, I could use syntax like this: free cursor, to say, take what cursor is pointing to, this node, and go ahead and free up that memory. But if I did that, what you'll notice is now suddenly I've freed up that memory, which means I've also freed up the memory that was allocated for the next pointer that gave me access to book and banana and all of the remaining elements inside of this linked list. So you'll want to be careful. If you free up some memory before you're done using it, you might lose access to the rest of the nodes in the linked list that you also need to free. So what's the solution here? We probably need some other variable to help us keep track of where we are in this linked list and to make sure that we don't lose track of any nodes. Let's go ahead and try this again. Here, in addition to a variable called cursor, which is currently looking at the very first node inside of this linked list, I'll create another variable called temp, which is going to be equal to cursor. They're both pointing to the same node. In other words, they both contain the address of this first node inside of the linked list. Now what I'd like to do is free this temp pointer, which is pointing to this first node, but I want to make sure that I don't lose track of the rest of the linked list. So what I can first do is say something like cursor equals cursor arrow next, to say, go ahead and move the cursor to the next element in the linked list before we free the first node. Now, cursor is pointing to the second element in the linked list. So if I run a line of code like free temp, I can free up the bat node without worrying about losing the rest of the linked list. Cursor is still pointing to it. And now I can repeat the same process. Go ahead and set temp to be the same thing that cursor is, have temp point to book as well. Then, to make sure we don't lose the rest of the list, go ahead and move cursor, and then we can free up the space that is allocated to what temp is currently pointing to. Free up that node and repeat the process. Have temp be set to the same thing cursor is set to, move the cursor forward, and then free up temp. And eventually, once you get through this entire process, what you'll find is that cursor is pointing to null. In other words, you've reached the end of the linked list. And at that point, that'll tell you that you've freed up all of the nodes inside of that linked list, and you're done, freeing up all the memory that was originally allocated for this node. If you repeat that process for every one of the linked lists that's inside of your hash table, the result will be that you've freed up all of the memory that was allocated for your hash table. My name is Brian.
تمام. دي كانت الانلود فانكشن دي هتعمله فري كل الميموري اللي انت عملت لها الوكيت. تمام. عشان نعمل كده احنا لو مثلا جبنا كرسر دي، تمام، خليناها تعمل بوينت مثلا لاول ايتم اول نود في الليست دي، تمام، اللي هي اقصد اللي هي بات يعني. تمام. هي دلوقتي كرسر دي بتعمل بوينت ليه. انا لو عملت فري دي، تمام، لو عملت فري الكرسر، تمام، هبقى عملت لوز اكسس لباقي اللينكد ليست. فانا هعمل ايه؟ هجيب كده فيريبل ثانيه او temp يعني، اللي هي دي اللي فيها بوينتر، ودي هخليها تعمل بوينت لنفس الحاجه اللي الكرسر بتعمل بوينت ليها. تمام. وبعديها هنقل الكرسر قدام، وبعديها هعمل في اللي في temp. تمام. وبعديها انقل temp لنفس الحاجه اللي الكرسر بتعمل لها بوينت، ونفضل نعمل كده لحد ما نوصل لاخر اللينك ليست، وبعديها نكون خلصنا اللينك ليست. تمام. لو في حد عنده اي استفسار يا ريت يقول.